Hi everyone, this is Clark Giacobakis, and this is the second session in our FSCI class on using R ORCID and R Crossref. This session is going to be focused on R basics, so just some general information on using R and understanding some basic functionality and some general functions that we'll use throughout the course. So I'm going to stop my video and share my screen here. Again, there's two different ways to access the course, the binder, Jupyter Notebook that we're going to be using for this one. The first is if you access day one from the course OSF page, and then you expand the wiki portion there by clicking on read more. And then you launch the one number 3 on R basics. You're going to launch that binder. The other way of accessing it is on the course homepage. If you click on the drop-down menu and go to R Basics. So this is more or less the same as what is going to be in the Jupyter Notebooks. Some of the information on this page is focused on using R and RStudio, which we're not doing for this class. So not all of this is going to apply. For example, that's a screen capture from RStudio. But it's the information is the same when it comes to writing R code, and this can be a reference for you in addition to the notebook. So the repository is starting, and as you can see, this is a preview of what we're going to be doing inside the Jupyter Notebook. So, while that's loading, I'll just go ahead and start talking about it. Okay. And each code cell is going to have a prompt when you click in the code cell, and that is going to prompt you to take some action. So when we type in a bit of code into that code cell, that is what is called an expression. And then when you run that code, it's called evaluating that expression. So as we talked about in our first video, there are a couple of different ways to evaluate code in Jupyter Notebooks. One is to press Shift-Enter, and that will evaluate the code and then jump into the next block. The next is to press Control-Enter. That will evaluate the code and that will stay in the same block. And then the last is to press Alt-Enter or Option-Enter if you're on a Mac. And that will evaluate the code and it will insert a new code block below. So for most of what we're going to be doing here, it's going to be a, let me look at this here real quick. I'm going to actually refresh it here. Try that again. Okay, that's better. So like, as I mentioned, Control-Enter will evaluate it and stay in that same block. So you can use R for basic arithmetic, as we've done here, 2 plus 2. You can also use it for more advanced mathematics as well as statistical analysis. For our purposes, the first operator that you're going to come across is what's called the assignment operator. And this is the angle bracket, which is the less than symbol, and the hyphen. So then there's no space between them. So it looks kind of like a left pointing arrow. So in this code block, what we're doing is we're assigning 5, the number 5, to the value, or the symbol, you could say, y. So once we do that, y is now going to represent 5. And sometimes you'll hear people say y gets 5. So another way of saying it is that lowercase y is now a numeric vector that has one element, and that element is the number 5. Now, when I run this, so I'm going to press Control Enter, nothing happens in the console, right? So it doesn't look like it did anything. The only indicator that you can see that something happened is this will turn into an asterisk just briefly. And I don't think that's something I mentioned in the first video, but the asterisk, whenever you see that running here, that means that the code is in process. Okay, so if it's a more sophisticated function that's going to take longer, you'll see the asterisk in the little number. All right, so now 5 is assigned to y. So if we now evaluate y, it will print 5 to the console there. Now, last time in our first session, we used print, and that does basically the same thing. It just makes it more explicit. And you'll see a number 1 there when you print y instead of just typing y. And that really simply just means that the number 5 is the first element of this vector. So you have a chance to try it yourself here. Assign 5 to y, then assign 10 to x, and then assign the sum of those to my total, and then print my total to the console. So you can pause the video and try that out. And I'm going to go ahead and show you how to do that. So 5 to y, and I'm going to press Shift Enter now, so I jump right into the next code cell. And I'm going to press Enter to go into edit mode. And then we assign 10 to x, so x gets 10. Evaluate that. And assign the sum of those to my total. So we say my total gets x plus y. And then print my total to the console. So I haven't evaluated this yet. So if I type in another line of code, that means it's going to do both at once, right? So it both evaluated the top line and created my total, and it printed my total. And then we could keep adding into it, right? Feel free to experiment in these code blocks. They're there for you to try stuff out. So if I put my total plus 10, let's say, now you see there's it's done 3 things. It's assigned 5 plus 10 to my total. It's printed my total, and it has added 10 to my total. Okay, so you can always feel free to do as much as you want. You just want to be careful if you're doing too much. It's kind of a waste of resources. So you may just want to do insert cell below, and you could say maybe square root of my total plus 10, and press Control Enter to evaluate that. So that's the square root of 15 plus 10, which is 25, and the square root of that is 5. Tips for assigning values in R: don't use names of functions that already exist. So we wouldn't want to call something like sum, say sum gets 8 plus 8. We wouldn't want to do that because sum is actually a function in R. So sum 10 to the 5, let's say. So you want to avoid functions that already exist because that's just going to confuse you and possibly confuse the system. R is case sensitive. So if I was to type in capital Y and evaluate that, I'm going to get an error because capital Y hasn't had anything assigned to it. So R is telling us this object has not been found. Nothing exists in this environment that's a capital Y. You don't want blank spaces, so you wouldn't want to say my data gets 5. That's going to give you an error because there was an unexpected symbol, and that unexpected symbol was a space. So if you do want to represent space, either use an underscore or use a capital. You don't begin with numbers or symbols, so you wouldn't want to say like 1 my data. Be descriptive, but keep your variable names short, because especially if you're going to be typing them often. All right, calling a function. R is what is called a functional programming language, which means that it contains a number of functions that that have been built that you use to do something in the R environment. So R comes with a number of functions already built in, but you can expand that by installing what are called packages. And those are functions that other people have written that will do other things. So you call a function on a variable by entering the function into the console, followed by parentheses. So sum is a built-in function in R. So if we take sum of 2 and 2, that's obviously 4. If you want to learn more about a function, you can press the question mark and type the function name in. So I'm going to do that here and give us a chance to look at this a little. And what this is telling us is you want to use this often. You want to read the documentation because tells you a lot. It tells you what the function does. So sum returns the sum of all values present in its arguments. And then it tells you what the arguments are. In this case, sum takes 2 different arguments. The first argument is represented by an ellipses, and that represents a numeric or complex or logical, don't worry about that. Basically numbers, and the ellipses mean any number of numbers. So you can have unlimited numbers that you will pass onto the sum function. So I could say sum of 2, 2, 1, 2, 3, 5, and it's going to sum all of those, right? The other argument there is na.rm, which that is what is called a logical argument, which means it has to be true or false. And the question is, should missing values be removed? So let's take a look at what that means. I'm gonna, and you set na.rm, you set that to true or false, okay? That's an argument that you are passing on to the sum function. So in this case, I'm gonna jump down here. Let's say we take the sum of 3, 4, and na. We're going to get NA, which is a symbol I'll talk about shortly, which means a missing value. So if we sum 3, 4, and a missing value, it's a missing value. We don't know what the sum is. But if we set the na.rm argument to true, that is telling this function that we want to remove any missing values before we execute the function. So that will look through everything that we've passed on to sum, and if one of those is an NA, then it'll be removed. So I actually should have added that in there. Let's say we want to take the sum of 3, 4, NA. We set NARM to true, and then we get 7 now because the NA has been removed. And functions can also be nested within each other. So let me go ahead and add in a new cell. I'm going to do that by clicking into command mode so that my cell outline is blue, and I'm going to press the B key on the keyboard. So let's say we take the sum of the square root of 9 and 4. She gets 7, right? Because the sum of the square root of 9, the square root of 9 is 3. And so we are summing together 3 and 4. And you can get really complex and sophisticated here. You can write out the quadratic formula. You can do quite a bit with nested functions. All right, I'm going to delete that. The next function I'm going to talk about is C, which is short for combine. And what C does is it allows you to combine values into a vector. And this is one of the most basic types of objects that we be working with in R. A vector is a number of elements combined into one. So the way to think about this is if you have a spreadsheet open and you have a name column, an address column, a phone number column, each one of those columns, name, address, phone number, is a single type, and it contains a number of values in it, right? So the names column is going to only contain names. and mostly those names are only going to be characters. A date column is only going to contain dates. So that's the way to think about a vector. And so vectors can only contain homogeneous data. So just like you wouldn't want to have a date in your name column, same deal. You only want a vector is only going to contain one type of data, and R will coerce it if it does not contain that data type. So here we'll use C to combine three numbers into a vector, and we're going to assign it to a symbol called my5s. So I'm going to press Control Enter to do that. Now remember, it didn't do anything because it did it in the back. I mean, it doesn't look like it did anything, but it did it in the background. So now we can use another function called stir, and this will give us some basic quick information about anything that we pass to stir. So what this is doing is telling us that my5s is a numeric vector of length 3, and then it's printed the first three elements. It's printed those three elements here. Now you can do operations then, just like we could add 10 to y to get 15 when y was 5. We can do the same thing for a vector. And this is one of the most powerful functions of R, is it's vectorized. So what it's done here is it's added 5 to each one of the elements, 5, 10, and 15. And that's something that later on, when we're doing operations with some of our other types of data, comes in really handy, because it will conduct that operation on every single item without you having to explicitly tell it to. All right, as we talked about earlier, missing values in R are represented with NA. So, if you ever do, decide to learn R and work with R outside of this environment, and you have data that has missing values, you'll want to encode it as NA, and you can do that easily in R. And because the reason for that is R has special actions when it encounters NA. And so one of those is, what I'm going to do here is create a vector that contains a combination of the first 5 letters of the alphabet. Let me insert a cell here. Insert cell above. So letters is the 26 letters of the English alphabet. So what I'm doing is taking the first 5 letters, and I'll talk about these brackets here in a moment. So I'm taking the first 5 letters of the alphabet. That's one part of the assignment here. And the second part is I'm repeating NA 5 times. So rep is a function in R that repeats. And rep takes 2 arguments. What do you want to repeat and how many times? So here I'm repeating NA 5 times. All right. And so when I create this vector here, as we see, it takes the first 5 letters of the alphabet, and it 5 NAs repeated. Okay. The reason I did that is I want to look at some of these functions using NA, because it illustrates some other important concepts of R. Is.NA is a logical test that goes through every single item in the vector, and it only works with vectors. It goes through each item and it evaluates whether that item is NA or not. So if it's not NA, it'll print false. If it is NA, it'll print true. Right? So here we have 5 falses, because those are not NA. There's actual values existing there, and then 5 trues. The opposite of that is complete.cases. And as we see, the exact opposite. These A, B, C, D, and E are complete, and then the 5 NAs are not complete. So what we're going to do next then is use the brackets like we did earlier with letters. 5. Use the brackets to subset my NAs. And then in that subset, we're going to pass complete cases And that is going to subset out anything that is not true, right? So it's going to filter out anything that's not true. The exact same thing would be to say mayonnaise bracket. And remember, because I didn't assign this to anything, mayonnaise remains unchanged in this environment. So if I run this, it's going to be exactly the same. And that's an important thing to keep in mind is any changes that you want, like let's say I wanted this to be permanent, I would say mayonnaise complete. That's mayonnaise. Let me delete that for a second. Now I can work with mayonnaise complete, and I see that that one indeed is changed, whereas mayonnaise remains unchanged. All right, I was going to show you what this is doing behind the scenes, this subsetting function here. It's exactly the same as if I did true. I'm just going to write T, even though it's bad practice. Actually, let me write the whole thing out. Sorry about this. So that's 5 trues and then 5 falses. 1, 2, 3, 4, 5. Okay, that's exactly the same thing. Let me comment this out so you can see. All right, so basically the point is that complete cases, or isNA, returns these logical vectors, true, false, true, 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 false, and then those can then be used to subset out based on whether it's true or false. All right, we're going to come back to this concept later on, so if that wasn't exactly clear, then try it on your own, maybe experiment a little bit with it, and we'll discuss it a little bit later on. Okay, there's a couple little exercises here, and so try this out, pause the video, and then come back and I'll show you what to do. The first thing is we want to assign the sum of 20 and 40 to my variable. Actually, no, I decided not to do that, so I'm going to delete that. The first exercise is to use the is function to check if average is a function. In other words, does something exist? Does a function exist in R to take the average of something? And it says no, object average is not found. So if we run is function on mean, it tells us true. And that means that a function in R exists called mean. And if we run question mark mean, we can see that mean is a generic function for the arithmetic mean. And it takes a few different arguments here, which I'm not going to go into right now. So I just showed you this as a way of letting you know that is function is one way of telling if a function exists in R. So the exercise is to combine 5, 10, 15, and NA into a vector, myVec. And remember that we used C here to combine these. If we didn't use C and we just tried to do this, you're going to get an error. Right? So you always have to use C to combine anything into create a new vector. Now let's go ahead and just print it out so we can take a look at it. 5, 10, 15 NA. So the challenge is to write an expression to get the average of numbers in myVec. If we just try to do the mean of myVec, we're going to get an NA. So just like with sum, If there's a missing value, it's not going to be removed. So again, illustrating this concept of passing arguments, we have to pass into mean the argument to remove missing values. Now we get the mean of 5, 10, and 15 is 10. All right, we've already talked a little bit about using vectors to using brackets to subset vectors, and that's what we're going to do here. Just like letters, state name is a built-in vector of all US states. And so when I run that, it's just going to print state name out here to the console. So just like we did with letters, we use brackets to subset it out. So the first state name is 1. Let's see, the 50th state name is Wyoming. Sorry, the first state name was Alabama. We can do the first through the 5th state name, which is actually what I did below here. Alabama, Alaska, Arizona, Arkansas, and California. What we cannot do is if we want the ones out of order, like let's say we want 1, 10, and 20, that's going to give us an error. And the reason for that is you use commas to separate numbers in a subset operation when we're dealing with data frames, or which I'll talk about next time, okay? So in this case, we just want state name. So if you want to do that, if you want the state name 1, 10, and 20, then you have to combine those first into a vector using C. And something else you can do is if you think you'll reuse that a lot in the future, like let's say my subset vector is a combination of 1, 10, and 20. Right, that's just 1, 10, and 20. Then I can subset the state name with my subset. And that will give us the 1st, the 10th, and the 20th state name. Right. We could also do that same thing with letters. We got A, J, and T. We could also do the same thing with true and false, but we have to first combine them. Okay, true, true. So because state name is a length of 50, what this has done is vectorized that operation, true to false. So it's taken the first, the second, skip the third, then it's gone back and looped. So if we go back here, it's going to take Alabama, Alaska, leave out Arizona, Arkansas, California, leave out Colorado. See how it's done that there? So that too is vectorized because it's a length of 3. And again, if you don't understand that concept, don't let it concern you too much. It's not key to understanding this course. All right, you can also use 2 equals to pass a name into your evaluation. And what that is going to do is it's going to evaluate every single item in the vector and return a true if it's equivalent and a false if it's not equivalent. So here, of course, we only have one state called Alabama, and it's the first one. So the first element is true, and the remaining ones are 50. We can wrap that in a function called which, and that will tell us which elements in the state name match Alabama. So in that case, we're going to get 1. And then finally, we can use our subset operation to say subset every subset this value to only return the true values, and the true values are where state name equals Alabama. All right, and then there's one final challenge here in R basics, and that is to first subset state name to include only element number 25. And what element is that? What state is that? Then subset state name to include 3, 12, and 40, and remember to combine those. And then a challenge, which element number is New York, and see if you can figure that out programmatically. In other words, don't just count it. All right, so pause the video and do that. And when you're back, I'll show you how to do this. State name, subset to include element 25, Missouri. Subset state name to include elements 3, 12, and 40. Arizona, Idaho, and South Carolina. Now, if we want to figure out which element number New York is, we could. Let's do it this way. Let's create a new object called New York and say New York is New York is state name equal to New York. And then let's say which state name equals New York. Let's see here. What did I do wrong here? Okay, we got our state name equals New York. Now we could just do it simple, which state name equals New York. And that's going to give us number 32. And I need to figure out what I was doing wrong there. So New York gets state name. And so that's a true false. Oh, okay. So you could say with name and subset it with New York. Nope. Argument to which is not logical. Oh, okay. The reason that didn't work is I passed you know what, don't even worry about that. I'll probably just cut this part out of the video altogether. So that will do it for this session. Let me know if you have any questions on the Slack channel, and we'll look forward to seeing you in the next one.